So welcome back. This is exploratory analysis of my data. I've done the data gathering. I've showed data gathering, data cleaning. So this is exploratory analysis. So I will divide this exploratory analysis into two. I have the A and B part. The reason for this is that I did some of my exploratory analysis in Jupyter Notebook, then I did some in Tableau. So the A part will be for Tableau, then the B part for Jupyter Notebook. So let's just get right into it. Okay, let me run this. Okay, I've imported my pandas. Okay, now this is CSV file which I got from my data clean. That is a cleaning data. So this is CSV file I got there. So okay, I create a copy like I normally do, then print it out. So I created a copy, then I run this. Okay, I just check an info for this. Just check the info. This is the data type, or the columns are the data type. So I also wrote this code to give me the max row, and I looked and I tried to get the descriptive statistics of all the columns. Let me run that. Okay, it has given me the descriptive statistics of all the columns. So these are the descriptive statistics for such. Okay, so let us remove unnecessary inconsistency from our latitude column. Now there are some there are some rows in latitude that have additional this inconsistent in it, and these have 5 points, have this symbol, so I have to change them. So run that. Then I convert the latitude, because the latitude was not in a float. It was not in a float data type. It was an object. Wait, let me check. Okay, object, and the longitude was in float, so I have to convert it back. So we will not have any errors when we're using it for analysis. So I run that. Okay, it has been converted to a float. Okay, so now I can convert it to a float. Okay, sorry, this is why I converted it to a float. So I convert it to a float here. Okay, this is as floats. So let's explore our categorical features here. Explore that. For the state, this is have the highest number of distributions, like state distribution. This has the highest facility, like 2000 something. Then when it comes to the ownership distribution, like the ownership, we have only public and private, like I've seen before in our data cleaning. Public has the highest. Okay. When it comes to facility, primary has the highest, primary, secondary, and tertiary. When it comes to registration, like I've seen, we'll use the value count. Registration have the highest. And we'll use the value count here. So yes. When it comes to inpatients, yes. Outpatient, sent to license. Okay. There's not much here. When it comes to this, primary health care again, general hospital. So that's the highest, because of primary has the highest in the facility level. So this one is the facility level option. Then for the local government, Mokwea has the highest. Okay. And others. For this one, unknown. There are some words that are unknown. So that's the highest there. Okay. The ambulance service, no, is the highest. It means most facility doesn't provide ambulance services in Nigeria. And there's two. Okay. Others. Okay, when it comes to ownership type, local government is the highest. Then for profits, which is mostly for the private facilities. Okay, let's explore our numeric features. Okay, just the same descriptive statistics we saw on the data cleaning. So there's not much here. Let me check. Now this is what we call a correlation matrix. So this correlation matrix is used to check the correlation between numerical features. Like, okay, let me run this code. It takes a lot of time to load while I explain. So it shows the correlation between different numerical features Seaborn. Okay, I will have to. Okay, it's lacking seaborn here. Okay, I will have to pause this video and then install, because I use this. I run the code in my second laptop, so I will have to reinstall seaborn here and then use it. Okay, we're back again. So I've installed seaborn, so let me run that. So as I was saying, the correlation matrix is used to check the correlation between two numerical features in your dataset. Like if what it means that they're correlated. What it means to be correlated is that once one numerical feature increase, the other one increase. So that's what the correlation means. Like let me say, okay, now this, like I said, doctor now. Okay, let me scroll down. And pharmacies are correlated. So what this is showing overall, why we're seeing 1 1 1 here, is that longitude and itself is perfectly correlated, because it makes sense that both of them is just the same value, so they are perfectly correlated. So once it's 1, they are correlated perfectly, but which is actually not possible when both of them are not the same features. But when it's closer to 1, then you have a strong correlation. When it's closer to -1, then you have a very strong negative correlation. But it's closer to 1, you have a strong positive correlation. So you see the difference. So all these ones are strong positive. They are strong positive correlations. Then these are negative correlations. This is a very strong one because it's closer to -1. I think so. Yeah, it's closer to -1. So that's why it's in dark blue. Then all these ones are in I think this is brown. Yeah. So these have a strong correlation, like this one, doctors and scroll down, and nurse midwife. And this makes sense that because most of the time doctor and nurse works together, so they should be actually correlated in some sense. Okay, that's what is happening here. Even this one to nurse midwife again and doctor. So okay, it's correlated. So that's what this correlation matters. And this makes our exploratory analysis like more simpler, because by looking at this you can just know which values are correlated to the other. Instead of doing it individually, you can just do it once for all of them. So these are the correlations. I gave a note here. So I said for the correlation matrix, we can see that there is strong positive correlation between pharmacist and doctor, which is 0.81. Now let me explain. When the numbers in the box are close, okay, I've explained that. Positive correlation and -1 negative correlation. When it is 0, it means there's no correlation at all. Okay, so since the pharmacy has a strong correlation with doctor, it means that the more doctor in a healthcare facility increase, the more the pharmacy also increase. So this also goes for the other health professionals, which is doctor to lab scientist, doctor to midwife, which you have seen in above. So pharmacist to lab scientists, lab scientists to nurse midwife. So for strong correlation, we have only between longitude and, which is not that important for our analysis. Okay, that is for strong negative correlation. So that was for the longitude. That one showed as -0.38. So it's not needed for analysis. That's why I will not focus on it. So now the 1 point that appeared diagonally, it just means that the column is correlated to itself, which is obviously to be perfect. So now, okay, after that, let me turn some column from float to int, because it doesn't make sense that like I've done before, because most of these are in int. Yeah, in this seems are float. So let's turn it back to int, because it makes more sense that way. Let's run that. So I have to also change the date too, because most of the time pandas used to misassign data types to columns. So you just do guesses. It sometimes may give you a wrong data type. So I have to run that. Then save this. I'll not run that because I already have the file. So it doesn't make sense for me to run it. So thank you all and goodbye.